Good morning, students. Good morning. So we'll continue with our chapter, like chemical bonding. We are almost, the last part of. Good morning, everybody. The last part of this chapter, chemical bonding, right? Okay, fine. So let's start now. So in this, we have finished Pajan's rules, right? We have finished dipole moment. So the last part that is left is molecular orbital theory. So what we have, in this chapter left is molecular orbital theory, right? This is the one which we have to do today. Okay. Student, just give 1 minute. Yes, student, we'll start now. Right? So what is left is the last part, molecular orbital theory, right? We have done this theory in the NCRT class. Okay. We'll do some questions. But before I do questions, right, what is the meaning of, let's start. What is the meaning of molecular orbital? Fine. Molecular orbital is a space where you can find the electrons in a molecule. Are you clear? Yes. Where you can find the electrons in a molecule. That's called molecular orbital. Fine? Clear? That is called molecule. Now, what is the meaning of students? What is the meaning of atomic orbital? Atomic orbital is the place where you can find electrons in an atom. Electron angular atom, that's atomic orbital, right? Molecules will use molecular orbital. Fine? And there are two types of molecular orbitals, bonding and anti-bonding. Fine. What is the meaning of bonding? I'll explain in a very simple way. See, suppose I've got two atoms, like let's draw H1, let's draw H2. Okay, students, now they overlap. Now see here. Just see now carefully. They overlap H1 and H2. Now this is the nucleus. Correct? This is the nucleus. This is the nucleus, right? This is the nucleus. Fine. Now you see, student, this area. You can see this area very nicely. This is called bonding molecular orbital. Okay. So I hope you are able to see. Let me check. Okay, fine. You are able to see. Students, I was just checking, right? You are able to see. So this region is called, students, bonding, yes, bonding molecular orbital, the common region, right? So electrons will spend most of the time here only. This is called bonding. Fine. Now what is anti-bonding? Anti-bonding, students, is this region. Can you see this region? This region away from the nuclei, can you see? Correct? Away from the nuclei, right? Correct? This region is called anti-bonding orbital. So between the two nuclei is called bonding. This is bonding, right? Okay. Away is called anti-bonding. Fine. Now, student, which is more stable? Bonding is more stable or anti? Obviously, bonding. Bonding means you are in between the two nuclei, right? Exactly two between, right? Bonding. Good, very good. Anti-bonding means you are away, not stable. Fine. So we'll have bonding and anti-bonding, okay, in this molecular orbital theory, and we have to fill electrons accordingly. Bonding you will fill first, then you will fill up anti-bonding, right? So all these things you'll be doing it. The theory part, students, I hope you have done in your NCRT class, right? So students, we will directly do the questions here. The theory part, we need not emphasize much. Now there are some terms here which are very important. What is bond order? So for every question, they'll ask you bond order. Bond order is nothing but half of basic summary. I'll revise for you. Half of number of electrons in bonding minus number of electrons in anti-bonding. Clear? Bonding and yes, defined as half of bonding electrons minus anti-bonding, right? Divide by 2. Suppose you take hydrogen, right? There are two bonding electrons and no anti-bonding. Hydrogen, if you see, there is no anti-bonding, right? So what will be the bond order? Half into 2 minus 0. You will get 1. Fine? So you'll get the bond order as 1, student. 1 minute, 1 minute, 1 minute. Okay, students, we'll continue. Continue. So you've got two bonding and no, and so you will get 1. Now, what is the meaning of bond order 1? Bond order 1 means, student, there's only one bond. So if I say 1 bond. Suppose I say oxygen, bond order is 2. What is the meaning of 2? That means there are 2 bonds. Is that clear? Bond order 2 means 2 bonds. Suppose I say bond order 3, then I will say 3 bonds. For this bond order is 3. BO means bond order, right? So bond order indirectly gives you the number of bonds. How many bonds are there, right? Clear? 1, 2, 3 like that. Fine? Obviously, higher the bond order, stronger the bond. Fine? That bond will become very, very strong actually, right? For example, can I say that triple bond is far stronger compared to double bond? Am I right? Triple bond is very strong compared, double bond is stronger compared to single bond. Am I right? This is about bond order. So the next thing they will ask in molecular orbital is, like, is it diamagnetic or paramagnetic? See, the other thing that they ask, is now what is the meaning of this? Diamagnetic means it will have no unpaired electrons. No unpaired electrons. Okay, all are paired. Now, if all are paired, like this I'm telling, right? You will get no magnetism. No magnetism. It will not be a magnet. Magnet, students, in Tamil, you know what you call Gandham, right? Gandham, iron. Okay? Yes. So diamagnetic now onnu varadu, no magnetism. It will not be a Gandham, right? Right? Paired electrons. But paramagnetic means you will get magnetism. Are you clear? And and this all depends on the number of unpaired electrons. I discussed this earlier also, students, right? So if you get more unpaired electrons, right, you will get more magnetism. Simple logic. Okay. So for that, what you have to do, you have to look the structure and find out, whether there's unpaired or paired. You just find out, and then you can decide, right? Okay. Fine. Fine, student. Now let us start the thing. Now let's start. Now, how do you fill the electrons? See, MOT means molecular orbital theory. How do you fill the electrons? If your number of electrons is less than 16, let me repeat once more. If the number of electrons, total number of electrons, right, less than 16. Okay. Now, before I come to this, in your syllabus, you will be studying only diatomic molecules. Diatomic and that also homonuclear. Now, what is homonuclear? See, HH. You see, same atom is there, homonuclear, same atom, right? And plus it is diatomic. Correct? So, two atoms, and this is only there for your syllabus. You don't have very complicated molecules, like clear. Diatomic homonuclear. Okay. Like we will study oxygen, right, nitrogen, all these molecules we'll study, right? Okay. So for this we'll calculate bond order and all that. Fine. And if the number of electrons are less than 16, then how do you fill the electron? Just see very carefully. Sigma 1s. Just pay attention here, very important. This is the electronic configuration of the molecule. Like we are right for an atom, right? We write for the molecule. Okay. Sigma 1s. Sigma 1s means 1s will form sigma bond only. Sigma star 1s. So next you will fill sigma star. So when I put a star stone, it is anti-bonding. I think you might have done this. This is bonding. Star means anti-bonding, right? Then sigma 2s. Then what will you get? Sigma star 2s. Okay. Then next is student. Now here there's a very important thing. Pi 2py is equal to pi 2pz. Pi 2py. Okay. Now please pay attention here. This py and pz will form pi bonds. Okay. And when I write equal to, what does it mean? That these two have same energy. That's why we're writing equal to. Now having same energy is also called, there's one more name given to them. I'll write on the top here. It's called degenerate orbitals. So if two orbitals, have the same energy, right? Then it is called degenerate orbitals. So pi 2py is equal to pi 2pz. Okay. Fine. Student, just give me 1 minute. 1 second you give me. 1 minute, just give me 1 minute. Yes, students, we'll continue now. Continue. Correct. Continue now. So now pi 2py is equal to pi 2p. That means what? Same energy. Then you will fill up sigma 2px. Is that clear? Then you'll go to star now. Okay. Again they are degenerate. Please remember these are degenerate, but they are anti-bonding. Okay. And the last one, students, will fill it up is sigma star. Yes, 2px, right? Clear? So, students, this is how you will fill the electrons, right? If n is less than number of electrons, n stands for number of electrons, right? Okay, less than 16. Let me repeat now. Sigma 1s first, sigma star, sigma 2s, sigma star 2s. Then you will fill up pi 2py is equal to pi 2pz, right? Then go for sigma, and then pi star, and then sigma star, right? Okay, students, very simple. This is if n is less than 16. If n is greater than or equal to 16, then the order will only change here, student. Will change only this part and this part. Just observe carefully how I'm writing. Sigma 1s, this part will remain the same. Sigma 1, this all will remain the same. Now here I will change to it. Sigma 2px. Yes, sigma 2px, right? Then pi 2py is equal. This part will remain the same, nothing wrong. Clear? So pi star to py, same thing. These are degenerate. Fine. This is what you will do if n is greater than or equal to 6. Now, shown one very important thing here. If you think logically, sigma should come first because very strong bond. What do you mean? Sigma means direct overlap. Am I right? Direct overlap. So actually, sigma should come first. Then it should come pi. Am I right? Direct overlap, very strong bond, right? So this is what is correct. Logically, this looks to be very correct. Clear? Sigma will come first, then will come pi. But why there's a small change here? This happens due to sp mixing. What happens, this s orbital and this p orbital, they'll mix. So due to that mixing, this order gets getting reversed. Can you see? You see this is coming first, this is coming second. Okay. So this happens only due to sp mixing, and I'll write on the top first. So this part is very, very important. Huh? So actually this should have been the order. Sigma first. But thanks to this sp mixing, S means this and this will get mixed up. So you'll see a small change in the order. Okay. Now you'll ask me, sir, why is this sp mixing only for less than 16? Well, why like only less than 16 you're getting it right? The reason is the sp mixing happens only for very light elements which have got less atomic number. Only for lighter elements it will occur. Why? Because this S and P, will be very close actually. So there will be mixing. So the sp mixing happens only for, I'll write here, this happens only for light elements. Is that clear? Yes, only for very light elements such as boron, carbon, light, nitrogen, up to oxygen. Fine? Boron, carbon, nitrogen. Students, are you getting it? So thanks to sp mixing, therefore you see the small change in the shift only for lighter elements. So whenever you're filling electrons, you should know this diagram, you should know this electron. Then you can keep filling electrons. Fine? Just note down this, just note down this. Very important. This is something, students, write, note it down. Very, very important for this chapter. So you need not draw that diagram. You just by heart this, you can do it. Fine. Now suppose I'll give you an example now. I hope you have wrote down this. Suppose I want to fill one electron, only one. I'll fill here. Two electrons. I'll fill it here. Okay. Three. I'll come here. Four. Again here. Five, six. Like that you can keep doing it. Okay. Five, six, seven, eight. Now 9, 10 students, be very careful. 9 electron will come here. 10 electron will come here. Ninth electron will come here. 10th electron will come. We filled up 8. Don't put both the electrons in one box. Put single, single. You know one rule called Hunt's rule. Okay, Hunt's rule, I write here. So according to this rule, if you are having degenerate orbitals, same energy, single, single, right? Okay. Then you keep filling the electrons, you'll get the answer, right? Fine, student? So please note down this fast. Very, very important. Okay, students, have you noted down this? Now we'll take some examples now. Let's take some examples. And let's take some very crucial examples. Let's take boron. Okay, students, boron. Boron has got 5 electrons. Okay. If you take B2, boron has got only 5. If you take B2, it will have 10 electrons. How much? It will have 10, right? Okay. So B2 will have 10 electrons. Now you have to fill, student, B2, right? Diatomic, 10 electrons. 10 electrons, how will you fill? So I will fill it up here only. Just see carefully. Sigma 1 is 2, 2 electrons. 10 I have to fill. 2 plus 2, another 2 here, another 2 here. And please remember, n is less than 16. So 2 here, 2 here, 2 here. 8 you already filled up. 8 filled up. Now lies the challenge, student. You will fill 1, 1, 1. Very, very, very important. Please make a note of this in your book. You will fill single, single. Remember, you have to follow Hunt's rule. Okay? And this diagram only you have to use because n is less than 16. SP mixing. Single, single. Okay? So, students, what will be the bond order now? How will you calculate the bond order for this? Alright, bond order is equal to half of number of electrons in bonding. Now, see very carefully how many electrons are there in bonding. Wherever I have not put a star, clear, that is bonding. I have not put a star. 2 plus 2, 4. Can you see I have not put a star there, right? 2 plus 2, 4. 5, 6. Let me repeat. 2 plus 2, 4. 5, 6 are there. 6 minus. Anti-bonding, can you see? Here and here. Clear? 4. So, I'm getting it. So, what will be the bond order? 1. Very easy. So, I hope you are getting this. Bond order 1. Okay, now tell me, is it paramagnetic? Yes, there are 2 unpaired electrons. Can you see? There are 2 unpaired electrons, right? So, it will be paramagnetic. So, students in exam, they will ask you bond order, paramagnetic, all these things. Fine. Now, they can ask you an exam like this. They can ask you B2 plus. Suppose in exam, they ask you, I hope you are getting this right. Note it down. Students, suppose they ask you B2 plus, what will you do? Then, there were total 10. 10 plus means 1, you remove 1 electron, right? Remove 1 electron, you'll have only 9. Is that clear? So now you have to fill up only 9. B2 plus. Plus 9 electrons. 9 electrons means you will stop here only. So you don't have to fill this, right? Okay? This is not required. So what will be the bond order? Half of number of bonding. Bonding will become now less by 1. So earlier you had how much? 6, right? 2 plus 2, 4, 5, 6. Now you'll have only 5 and this is 5 minus 4. So you'll get students bond order is 0.5. So bond order has come down. Can you see? So if you remove electron, bond order has come down from the bonding. 0.5. Okay. Still paramagnetic only. But what question they can ask you in the exam? Suppose they ask you B2 versus B2 plus. Which bond is stronger? Okay. Bond stronger means the BB bond. Is it stronger in B2 or is it stronger in B2 plus? The BB bond. Strong here or strong here they can ask. Right? The answer will be the stronger in B2. Why? Because B2 has got a bond order how much to 1. B2 plus what is the bond order? 0.5. Clear? They can ask you this question. Very strong bond BB. One bond order 1. Clear? You are getting only 0.5. Second thing, they can ask you about bond length. Now, stronger the bond, very simple logic, obviously. Stronger the bond, right? Shorter the bond length. Is that clear? So the bond is very strong, right? Bond length will become very short. Fine, student? That's how we'll do it. Very simple. This molecular orbital theory is not that complex. Only you have to fill the electrons and tell, like, clear? Fine. So students, can you note down this fast? So let's take some other molecules. Have you noted down? Let us take some other molecules, but please remember this theory is very, very important. Okay. Let us take C2. Now C2 students will have total of 12 electrons. How 12? Tell me. One carbon will have 6. So 6 twos are how much? 12, right? 12 electrons. 12 electrons, how will you fill? Tell me. Sigma 1s2, sigma star 1s2 as usual. Okay. Yes. Sigma star 1s2, sigma 2s2. Getting it? Sigma star 2s2. This two as usual, right? Then we come to the most important thing. Pi 2py is equal to pi 2pz. Now students, already you have filled up 8. Just check 2 plus 2, 8 you have filled up. 1, 1. Correct? Now 10, 10. Now we make it as 2, 2. Okay? Make it as 2, 2. Now just check. Have you filled up 12 electrons? Or you have filled up 12, like clear? That's all. You don't have electrons after this, right? Clear? They're all vacant. Now what will be the bond order? Bond order will be how much? Half of number of bonding. Bonding you will get 2 plus 2, 4. 4 and 6, 8 you will get. Just check it up. 2 plus 2, 4. 6, 8 minus. And these 4. Right? Anti-bonding you will get 4. So you will get 2. So bond order you will get students 2. Okay. And students it will be diamagnetic. Why diamagnetic? Because here if you see the electrons, right? The electrons they are all paired actually. Okay, the electrons are all paired. Okay, they're all paired. Fine. You see here 2, 2, like they're all paired up, so it will be diamagnetic. Fine. Now, very important students, this is the most important thing. If you see two bonds, what is the meaning of bond order? 2 means you will get two bonds, right? And both the bonds are pi bonds. Can you see pi pi? So carbon C2, two bonds are there, and both the bonds are pi bonds. Can you see? This is also pi bond, this is also pi bond. So that's very interesting. Pi bond, pi bond. Normally we say that when carbon forms a double bond, we say one bond is sigma, one bond is pi, na? This is what we say normally, one sigma, one pi, right? But here you get surprisingly, you get both the bonds as pi bond. That's the beauty of molecular orbital. Something very interesting, right? Okay, please note down this point. So you get both pi bonds, right? Okay, please note it down. Yes, I think you are not able to see this part. So I'll write here diamagnetic. Okay. But here one interesting thing, both are pi bonds. Fine. Fine, sure. That's about C2. Now we'll go to the another molecule which is very important, O2. Now, so O2 is something which is the most important molecule in this molecular orbital theory. Okay. Now see, we'll see this molecule first. For O2, how will you draw the sequence? Sigma 1s, sigma star 1s, sigma 2s, sigma star. I think we'll fill the electrons. O2 means how much? 8 twos are. 8 electrons, right? Total. Remember, you should take the total electron, not the valence. Total always total. So 8 twos are how much? 16 electrons, right? So you have to fill 16 electrons now, 16. Okay, now see here how we are filling it up. So I'll start from this end. Okay. Sigma 1s, sigma star 1s. I'll put the electrons also 2, 2. Sigma 2s 2. Sigma star 2s 2, right? Okay. Then what comes to end? Remember now there's a change in the diagram. Please remember that. Now what will come is sigma 2px2. Then pi 2py is equal to pi 2pz. You have to fill 1 1, but then later on 1 1, but then later on it becomes 2 2, right? Now students, tell me how many electrons you have filled till now? 8 plus 2, 10. 10, right? 12, 14. 14 you have filled up, right? Now you have to fill 15 and 16. So you will fill 1 1 electron here. Pi star 2py is equal to, correct? 1 1 electron. Okay? Now see the fun. Now see the very important things. It's very interesting, funny, right? Very interesting. Oxygen has got 2 unpaired electrons. Now this is something, the greatest success of molecular orbital theory. You see, it has got 2 unpaired electrons, so it is paramagnetic. Student, that is a very important thing why oxygen plays such a vital role in photosynthesis. You know that plants synthesize food and all that, right? Oxygen is, because it has got unpaired electrons, it is reactive. It's reactive. Normally, if you've got unpaired, become more reactive. Clear? It's paramagnetic. It will be attracted by a magnet. Okay? Your valence bond theory, if you draw the valence bond, remember the dot structures you have done earlier? You should draw dot structure like this, right? Okay. Correct. Now, if you just check it out, 4 plus 4, 8, yes. Now, if you see these structures, these structures, the electrons are paired, na? Correct? If you go by this, the electrons are paired. Whereas oxygen has, this theory proves, molecular orbital theory, proves that oxygen has got unpaired electrons. And experiment also shows unpaired electrons. If you do experiment and find out oxygen has got unpaired electrons. Clear? So that means this is the greatest success of molecular orbital theory. Very big success. Fine. In fact, students, you should not take oxygen near a magnet. You'll get attracted. I'm talking of liquid oxygen. Gaseous oxygen doesn't have magnetism. Doesn't have, but liquid will have. Okay. So oxygen cylinders, when they carry oxygen in cylinders, right? The magnet should not be a mobile phone and all. You should not take near a oxygen cylinder. Should not Take near oxygen. Why? Because mobile phone has got some magnet, right? Oxygen is also magnetic. Mobile phone magnet, oxygen magnet, right? They'll get attracted. I hope you're getting it. Because oxygen is magnetic. You'll get attracted by the magnetism in mobile phone. Okay? It's magnetic. This theory doesn't show that. Valence bond theory. What is this? Dot structure or VBT, whatever you call, no, like VBT, right? This theory shows. That's the biggest success of molecular object theory. Okay, Swan? So anyway, oxygen has got two unpaired electrons, right? And it is bond order we will get as 2. Okay, you will get as 2. Paramagnetic. Okay. And one more thing, student, they ask frequently in the exam, very, very famous question. O2 plus, O2 minus, O2 2 minus. Every exam, they'll ask this question. O2 plus, O2 minus, O2 2 minus, right? What are their bond orders? You can find out easily, not a difficult one. What are their bond orders and just check whether they are diamagnetic or paramagnetic, right? Very, very important question. Okay, so just note it down, just note it down. Okay, Swan. I hope you have noted it down. So O2 plus, you can calculate the bond order. I think we'll get 2.5. So O2 plus has got higher bond order, you see, compared to oxygen. Just check it out. It will have 2.5, like. So we can say O2 plus is even more stable than O2. O2 is just 2 only, right? It's 2.5, right? Okay. More stable. Like so, like that, you can do for the other ones, O2 minus, O2 2 minus, right? Okay, students. So I hope you have understood this part, like fine. That is the end of this molecular orbital theory. It's a major success for oxygen. Okay. Okay, then students, fine. We'll wind off here, right? One more thing I want to tell you before we wind off. Just see, very simple. Of course, they don't ask this in the NEET exam, but still, suppose they give you CO. Suppose they give you CO. You just check the atomic number of carbon, 6. Oxygen is how much? 8. So how many electrons? 14. So 14 electrons means, tell me a diatomic molecule same as 14 nitrogen. See, nitrogen has got 14. We also got 14, right? Okay. So whatever bond order you will get for N2, the same bond order you will get for CO. I think the bond order of N2 is 3. Bond order, you will get for N2 3, right? Triple bonds. Same thing you will get for CO. So you can easily find out. Very clear? These are called isoelectronic. What are they called? Isoelectronic. So whatever answer you are going to get for N2, the same answer you will get because same number of electrons, right? Clear? Fine. 14, 14, right? Is that clear? So this also you remember, very important. Okay then students, that's all about molecular orbital theory. So just check the number of electrons also. Okay. Okay then bye. We'll meet next time. So this almost ends your chemical bonding chapter. Okay, almost ends it. The small things are left, right? We'll do it next time. Okay. Okay then bye. See you. Next time we'll see you, right?